Now it's ready. I'm gonna share the screen. Okay, so I created a fresh VM, and then I will open the instructions that are also available on the link I provided before. Here, KubeEdge, and then we go over SEDNA, and then there is the README file. So we will go with the simplified Kubernetes plus SEDNA installation. The advanced one, as I mentioned before, is when you want to have also KubeEdge. But it requires extra steps, and I don't want to make this way too long because I know it's the last session, so I will try to focus on what's strictly necessary, and then the rest you can try it yourself.
Yeah, so this page is also very small. Can you make it bigger? Yeah. Thanks. Yeah, should be fine. Yeah.
So the first part, we will install like the basic components like Docker, Kubernetes, and SEDNA. So it's kind of an infrastructure setup. Some of these steps probably you're already very familiar with them. I will go over in case, just to make sure that you got them right. Then part 2 is when we run the READ application. So it will show you how to, what kind of CRDs to create and how to set the NFS, set up the NFS, and a few steps that are needed to go ahead. Here is it's recommended to have this kind of specs, but I mean, it's not necessary. You can run also with less CPUs. It depends. Because it's a standalone node, you're going to have a lot of things running on it. So it's better to have more RAM and CPUs, but in general, you don't need this much. And then we are going to use the resources in the repository that here under REST, there are some YAML files and also the AI models that we're going to use. Okay, so the first part we're going to install Docker. So most of these commands you can just copy paste. Sometimes copy pasting directly from terminal does work if you copy the whole block. So just double check. Going update, installing Docker. Okay. We are going to enable it, check its status. Running, it's great. Then this is to add the current user to the Docker group. We're going to run it later. Then we install Kubernetes. Here is the usual step that you can also find on the tutorial online for Kubernetes for the installation. So let's go through this. Get the key. Sometimes, okay, work. Sometimes this might not work, and then I need to do some extra steps. We're going to do the update. Then we're going to install this this specific version 1.22, and then pin it. Hold it, not pin it. It also works with the latest, but this one is when it was tested and it works for sure. Then we need to disable the swap. This is because Kubernetes doesn't like swap, which is one of the main components for Kubernetes. So we need to turn it off for now. You need to run this if you want this to be permanent, but in this case, we're not probably going to restart this machine. We're going to restart Kubernetes. We're going to just check if it's live. What's the problem with this? Let me stop and see if there is something else annoying it. Yes, it's because the The C group driver for kubelet is different from the one from Docker. Docker is using systemd. It's weird because I didn't have this problem on the other machine, but let's see. Don't remember exactly what's the status here. Status. No, it's the other one. It's a second. I need to make it so it uses the different group. Yes, I think it's here. Where is one? Sorry about this, but I'm not. So I have this command and it works flawlessly on the other machine. So I don't know why the Docker is using a different group. Just give me a second to figure it out. Please no. Check on the other machine if there is something here. Okay, so we continue with the other machine because I don't know why on this one the system, so there is a different configuration for Docker. They are exactly the same, but I don't know. Anyway, so if assuming that this went fine and Kubernetes is running, which is, for example, on this machine, this is like on a machine where the cluster is installed, so this it's running. Then the next step you will do is to initialize KubeADM, which is the manager for Kubernetes. So we will like launch this command, which initialize KubeADM, which is a tool that we also installed on this machine previously, this one. And through the initialization command, you can create the Kubernetes cluster with a specific control plane. And what you're going to pass is the master node IP. So it's the IP of the machine. In this case, for example, would have been this one, because we're going to use the internal IP for the to initialize the cluster. And after this command is launched, what you can do technically is, because this is a single node, you don't really need it. But what you can do is to create this CIDR, which is basically the pod overlay network. So when you have multiple nodes and you want these pods are running on different nodes, for them to communicate, you need an overlay network that on top of the one you already have. In this case, it was installed Calico. And when you launch this command, it will create basically we use this YAML file to create a set of pods that you need for the network. And then it will untaint the master so that these pods can also run on the master, because you have a standalone installation. And if we have a look at the pods I have here, let's see. So these kube system pods, these are the ones that support basically the overlay network, and they are all running state. Then this is just some utils, let's say. So you can modify your bash RC to have the auto completion, so you don't have to write kube control all the times. And at this point, if following this tutorial, you should check that all the pods that are running, all the pods in your cluster are running and in good state, which is the case, for example, for this cluster. You can ignore this one because we don't use it, so it's not a problem. It's part of SEDNA. We see later. But everything else is running. Especially what is important is that the kube system pods are all in running state. After that, we will have to install Go and other build tools. So we're gonna we need to build SEDNA, at least some of components from source. Normally, the images are available online, so you can just pull them. But in this case, what we will do is basically to install the tools that we need, which is Go and some build tools. And then we will proceed to install SEDNA by cloning the repository, then cd into the SEDNA folder. And then there are a set of commands that we're going to run here. There is also an automated installation available in the repository, but there are some problems that, you need to solve it by changing something in the script, which I think it would be a little bit too complicated. So what was done here was to create the CRTs and this the role the access rule for the global manager to basically talk with the cluster. And then I will show you what are these. So this would be CD, then build, then we have the CRDs. And each CRD is basically associated to one of the example I talked about before. So for example, we have the one for the feature extraction service, for the federated learning job, for the incremental learning job, and joint inference service, lifelong learning jobs. Because this means that when we create them, we register them on the cluster. We allow SEDNA and Kubernetes as well to be able to interpret when we submit this kind of AI jobs to the cluster itself. The one, for example, we're going to use in this tutorial is the feature extraction service, the video analytics, and the ReID. And the three of them together basically allow to run the workflow that I showed in the slide. So to analyze the video and identify someone in it. Then there is the SEDNA models. This one is for register models against the cluster. So you want to, it's kind of to say this model, YOLO X, for example, is available, and you can use it inside your, YAML file definition. You can say load this model with this name. So this, by following the tutorial here, we will create basically all the files in the CRD. So all the YAMLs will be basically what I can show you here. I cannot do the build, but I can do, for example, I can apply them. Some of them I cannot apply because they are too long, but basically it's telling me that these resources are not changed apart from the last one. And so if you would have used the create, basically you would have like automatically created these resources against the cluster. The same is for the RBAC. This is something you just do to allow permissions for the global manager. Now, building from source. So this is just to create the resource definition in the cluster. Now we need to build the images. So we need to make the images for the knowledge base, for the global manager and the local controller. Before doing that, we just need to change in the make file that is in the SEDNA folder. I'll show you. There's a make file here. We're gonna just go to the image tag, this one. Originally it's 3, but you can set it to, you have to set it to 5. And then you can just run make and make image. Make will build the code first for you, and then it will build the images, which are, for example, I will make just one. I will make the KB image. We will just invoke Docker and put all the libraries inside that load all the libraries that are necessary, the code into this KB image, and basically tag it so that you have it. In our case here, we have, so for example, the LC, the GM and the KB, which I built a few days ago, but basically is the one that you're gonna use and deploy. Again, these images are actually available online, but not for the version we are running now. We are showing now for this example. After this, then we have the image, right? Then we need to deploy SEDNA on the Kubernetes cluster. To do that, we're gonna use what's in the res folder of this repository, which is training SEDNA resources. Here I provided you with a set of YAML file that allowed, once they are like when you do create, this gm.yaml will basically deploy the global manager on the cluster. There is a note here in the tutorial. It reminds you that you have to edit only the local controller to use the IP address of your master node. So it's basically the same node that this one. So if I do cut here, I can see that you need to modify the GM address with the address of this node. Then at this point, again, you want to check if everything is running correctly. So you do kube control get pods -a o y, and hopefully at that point, you will have the GM running correctly. The knowledge base, you can ignore it if it is a crash loop, and the local controller. So as long as these two are okay, then you are fine, at least for the example we're running now. Let me see if I can show you some logs from manager, what it does at the beginning. So when you first deployed the global manager, it's interesting because it shows you all the controllers that is creating based on the CRDs we registered at the beginning. We created at the beginning. So here we have the lifelong learning example, the further learning, the incremental learning. So he's able to manage data sets, he understands what the READ is, and so on. So this happens because we have custom controllers into the global manager that know how to handle these specific AI workloads and what to do with them. And for example, a user that is proficient with Kubernetes or like knows how to create custom controllers can modify SEDNA to have new controllers that are able to handle new types of AI workloads. And you can define, for example, how the pods should be created if you have some specific rules, what to inject into the pods, and so on. One thing I will show you is what is usually done with the models, so how the models are injected into the pods, and basically what is the logic behind that is managed by SEDNA for this. So assuming that we are here and everything is fine, we can, so the infrastructure part is completed and there is nothing much to do beyond this point. If you have a single node, if you have a multi-node, then it could be a little bit more tricky. So the application deployment part is basically an excerpt from the tutorial that you find on the SEDNA webpage, this one, which is about using REID to track an infected COVID-19 carrier in pandemic scenario. And this basically, there are a lot of details here. It tells you what is the purpose of this application, why the workflow, how is this done. But I decided to basically extract only the meaningful information for you for this workshop, while the rest was like, it's left to, if you're interested to you, if you want to go to the tutorial and read more. So there are three main steps. So the first one, we need to use, because we use kind of persistent volume, so we attach volumes to the pods. Then the easiest way to do that is to set up an NFS. Now, this is a single node, so it's a little bit overkill. If it will be multiple node, it will be a little bit make more sense. In general, to set up the NFS only in the current node, you just you run these commands, which download the NFS kernel server. They create some directories we're gonna need later, and it's gonna export in SERI. So this folder is always exported. And then if we do this command, at the end, it should tell you which folders are available, they are mounted. In this case, so this, if you have this output, if you see this output, then it means that everything is fine. And then if you go to this directory, there will be these folders that you just created, plus now you see also the video. It's because that's where we will put the video that we want to process. These folders are shared with the pods that we will run, and also are also visible from other nodes in the network in your cluster. So this is useful, for example, if you have an AI model and if you put it on the NFS, then other nodes can also see it and access it, so you don't have to copy it. You just have one point where you put everything. So it's also for convenience when you want to try something out with multiple nodes. Then we use this PV and PVC for this example. So I don't know if you know about it, but I'll tell you briefly what they are. So a PV is it's a volume basically that you create in the cluster. You specify how big is this volume, how many gigabytes, and on which node it resides. I will show you what I mean by that. So the YAML files are available for this at this location inside the SEDNA repository. YAML, so SEDNA examples, multi-edge inference pedestrian tracking. That's basically the example I'm showing it to you right now. Then you go here and you go to PV. And there is one volume, it's called the REID volume. this volume, this persistent volume has specific storage capacity. Here is set to 10 gigabytes. You can be less. It doesn't have. It's just a number to. There's plenty of space for what we're going to do. Because we mounted connecting to NFS, this is like typical. This is Kubernetes. It's not a SEDNA stuff. It's just Kubernetes. Then we have to pass the path to the NFS and then the server where this NFS is running. Then you will proceed to basically create this volume. I don't create it again because I already have it, but once you run the command, what you can see is here you can get the PV, so the persistent volumes in the cluster, and it should appear this line. So it will tell you that it exists, it has this capacity. And in this case, it's bound, and it's bound because the claim, so what we create afterwards, this claim, has been already created, okay? The claim just says, oh, I know that there is a volume, I want it for this purpose. So, and I want this volume with this name. So let's have a look what's inside. It's the volume claim, and then we pass, it's important that these metadata names match, otherwise, and also the volume name match, so that you can kind of find it, because there could be multiple volumes. And if you're just saying, okay, out of the 10 gigabytes, give me 5 that I'm gonna need, because they can be shared, the volumes can be shared by different claims. And then when you go here, just check, it's bound. When it's bound, it's always good, it means it's working. And we are done. So this is what you have to do for this step. And it's kind of explain why this is done this specific way. As long as they're bound, then we don't have to worry about anything anymore. Then the last thing to do is to set up Kafka. So differently from the other examples that are heavily reliant on REST, so communication to REST API, I wanted to show you something that is a little bit different, and could be, it's technically a little bit more in line with let's say more production-like deployment. So when you have like your data plane is not just REST API calls, but you have like a kind of a persistence. You want to make more resilient, so you have like a Kafka in this case, which is a pub subsystem to write and read data from topics, and then you have this PVs, like persistent volume. So it's a little bit more convoluted from the Kubernetes point of view, but also makes it a bit more sound from the system perspective. So to do that, I also provide here the YAML files, deploy Kafka and Zookeeper, because one needs the other. So what is mentioned here is that you need to edit each one of these files, so that whenever you find, for example, the like master node IP keyword, you replace it with the IP of this case, the master node. I will show you, for example, if I go to the broker deployment, the broker deployment would have had here like kind of a dummy value like master node IP that you will have to replace with the IP of the node, of the master node you're running the example on. And the same, for example, is for Zookeeper. For the deployment. No, I think it's for the service. Service. Will be here external IP, and then you have to make sure that you replace with your IP. Once this step is done, you basically can just do k create -f and then Kafka like this. So it will create all the YAML files that are in the folder against the cluster. And what you will have, what you should have at the end, is that when you do k get pods, you will see the broker running and the Zookeeper. It might happen that at the beginning, some of them, they go into restarts because, for example, Kafka starts before Zookeeper and then it fails and then it restarts until it synchronizes. But the idea is that at some point they should get to the running state. And these are tools used as they are out of the box. They are not modified. I mean, the logs for this, I think it's not important to show you what's inside Zookeeper and Kafka. One remark, this application, today I will show you how it works with Kafka, but in general, it works also just with REST API. So let's say you don't want to deploy Kafka, you don't want to deploy Zookeeper, then in the tutorial, in the full tutorial, in the link, in the other link, then it's explained how you can have it work just with REST APIs. So you can also skip this Zookeeper with this Kafka part. Then finally, we are at the moment where we can actually deploy our application. So before we go ahead, we need to make sure that we have the models. So the models are in here, KubeEdge, SEDNA, resources. We have the YOLOX model and M3L. The YOLOX model is the one used for detection and tracking, while the M3L model is used for the feature extraction, so to extract feature from an object, a pedestrian, for example. What it tells you is that you need to be careful. You need to, if you want to use the YAML file as they are in the SEDNA repository, then you need to do the following. You need to, on the node that is running the video analytics job, now we only have one node, so it's always the same. We need to copy the YOLOX PTH inside this folder. And if it doesn't exist, you create, okay? And the same you need to do for the feature extraction. You copy it to instead these other folders. This is important because now I will show you these models here that we create now against the cluster. They point at locations on disk where the model can be found and loaded. So if I go back to here, YAML, there are the models. Oops. And for example, if I open model detection, there is this kind model. So this is, again, a CRD created specifically for SEDNA. So it's something we created new for SEDNA. It has some little details, but then what is important is the URL. So where the model is expected to be found. Because if the model is not found, then it could go into a silent failure when you deploy the pods. So they could go, for example, in eternal pending state, and you don't know what is happening. And usually it's because maybe they're not able to load the model. They cannot find the model. And the same is similarly is for the M3L. So you're gonna have a specific name for the type of for the model, and then when it can be found. Following this guide, you will create these resources, and then they are registered against the cluster. Actually, I will show you. If I do kget models, tell me that these two, there's some extra information to show. No. Okay, it's going to tell you that these two are available in the cluster. Okay. Now to run the application, we need, here is said we run everything on the master for simplicity. To run the application, we need, we need a video. So what we want to analyze, a source video, and then we need the query images. So I will show you what I mean by that. First of all, replicate exactly as the example. You will find in training the resources you need. Here, there will be a zipped folder, which I unzipped here. So if I go to test video, you're going to have the source file, test video MP4, and 3 query images. Okay, the 3 query images. Are these ones. So 1, 2, and 3. And these are basically the image we provide to the identification module to find this person in the video. Okay, but let's go step by step. So these are the resources you need. What you're going to do if you want to stick to the tutorial, so exactly, you copy the JPG inside the NFS in the query folder. And then you copy the video into the REID folder. So you do these two steps. So you take the resources I provided you and you put them in the NFS. At this point, what we do is to start the only service. So we have 3 pods. Only one of these is a service, so it's always running. And in this case, it's a feature extraction service, and we need to check that it's healthy. So you go to, again, SEDNA example, pedestrian YAML. Then here there is a feature extraction service. Before launching it, we need to have a look at it, because also I think this is interesting to see. For example, here we specify that we want to use Kafka. So we have Kafka support true. And as you can see, this is not a typical Kubernetes syntax. So this is something that we have because our controller in the global manager know what it means. And the same applies for model. So we're saying this pod, this feature extraction service, this deployment needs this model with this name to be loaded, to be kind of loaded into the pod so they can be used. This is the image we're going to use. That's why there is no need for you to build the images for these applications, even for these pods, even if we provide everything to build them, because they are available online in this case. What needs to be changed is the IP here. So here there will be a dummy value, and you need to replace it with the IP of the master node. In terms of resources here, like you can play around with them, but in general, this is sufficient. There's just a little bit more extra memory in case you're transferring, for example, big images and so on. And there is one replica. This we will create it doing launching with this command, which I'm not launching now because it's already available in my case. I will show you what's in the logs. This is a feature extraction pod, and the first time you start it, it will tell you that, okay, I'm using a CPU because there is no GPU in this VM. It loads the model, it just checks everything is okay. It knows, so it kind of loads some internal classes to, it's kind of plugins that allow it to know that it will talk with the video analytics pod or service. Then it set up like the feature extraction interface. So this is what it's always done if you, because if you don't have Kafka, it at least has REST interfaces. And is this output tells you basically that is open to communication also with REST APIs. And then it will connect to Kafka because we set it to true. Okay, it has kind of it tries to connect to the IP or using the service, and then is waiting for basically images from this object, from the object detection topic, and you will write to this enriched object topic. So here you see already message published because this was a test that I ran, and it's basically whenever you see this, it means that it's actually working. Now we are ready to kind of launch the video analytics application or pod. To do that, we need to go to the video analytics job YAML. We need to tell to this pod where is he going to find the source video. Again, Kafka support has to be true, and this is a job, so it means that once it's done, it's going to go into succeeded state, and then it's done. Basically, we can undeploy it. What's important is, again, put here the IP, and then this one is the video address. So where is this video coming from? In this case, we can just give a path. There is the test video MP4, which is on disk. In other cases, you can use many things. I support RTSP, so a camera. It supports HTTP. So if, for example, it's like a video needs to be downloaded from like a remote location and then processed, or like the file loaded in this case from the NFS. What is a little bit different is that, for example, how do we mount? So that's where the persistent volume comes into play, is that here basically we are saying we need to to get the claim and to mount it at this location. So I want to see what's on disk, display, this location, so that I can access the video, I can access the files, and so on. Once you configure it, then we can create it. So we can use this syntax to create it. And then if everything goes well, at some point, you will see it will go into succeeded step. It's important to notice that depending on the video, so now this video is small and simple, and it will not take too long to process it. But if you are running, for example, you're processing a stream and you want to kind of, you need to kind of know, like you need to limit, okay, the ingestion rate. If you have an ingestion rate that is too high, which is represented by the FPS value, the FPS parameter, then you might go into out of memory. Okay, so you need to be careful with that, especially because this was one of the first versions that we released, so it was not that adaptive, let's say. I'm gonna create this and get pods. It's in running state, so it looks good. We want to see what's inside. It's going a bit fast. Let's see if I can stop somewhere. So what he's doing is he found, so we try to remember, we gave it the video address, so he's loaded it, and then it's going frame by frame. So it's starting on frame 0, it's patching, okay, images. And then in this image, so in the first frame, he saw 2 objects, in this case 2 people. Camera ID is just a dummy value. It's useful when you have actual cameras, okay? And it assigns ID 1 and 2. So the IDs, if you had like 10 people, would be like 0 to 10 and so on. And the IDs are very important because these IDs are kept throughout the whole video processing. So if a person moves, it will always have the same ID based on like some constraints, and it allows you to track it. That's why for this COVID-19 is important, is because you can track the same person across different video streams and maintain the ID. And then after this step, basically the processing of the frame ends, and it will transmit the result to the next component, which is the feature extraction. Okay, here is going to tell you like roughly how fast he's going. To do the transmission, because we're using Kafka, you're going to see this message which tells you, okay, I published the result on this topic, object detection, with this offset, okay, because there were others before that I wrote, because I tried other before this example. And then it keeps going and going. Now the FPS depends a lot. This is a CPU, like on GPU it could be like 10 times faster than this. It's just a matter of like what hardware you have, the underlying hardware you're using. So the workflow is the following. When we write something into the topic, Kafka, so the feature extraction service, we read from it, process the data, and send it back. That's why we see a lot of these lines receive data from a feature extraction module, and this is the counter. And then we write to local storage. But what we write to local storage, and apart from the fact that the job completed successfully, is the following. So I'll show you what's in here. It's a lot of these DAT files. These DAT files is basically what the REID, then the final module, the REID will read from to do the matching with this on-the-fly matching. Is kind of our gallery. Okay, these are all the images. Okay, plus all the extra data provided by the feature extraction, and they are ready to be analyzed by the REID. So we have a look at the pods. Video analytics completed. So we don't need it anymore. We're gonna go back to our example folder here with the YAMLs. What we do is that we can delete video analytics, because jobs, once they end, they remain this completed state. They don't get deallocated. They don't get removed from the cluster. So we're going to make sure that it goes away. So we delete it. And in fact, it's not there anymore. The feature extraction is still running. And actually, we can check the logs to see if it communicated properly with, I mean, we know that it communicated because we see the video analytics logs, but let's have a look anyway. So what happens is that when we see this message published is what then the video analytics will see on the other end. Okay, so it's receiving back the data from the feature extraction after it does its processing. At this point, the last part is the second part 2 of the workflow is to deploy the re-ID job. Before doing that, we have a look at the YAML. Kafka support is false because this once reads from disk. It doesn't read from any Kafka topic. So we don't need Kafka. There is a matching threshold. So the re-ID is based on a threshold that allows me, the lower the threshold, the more like false positives we get. Here we have 0.35, but it will print, the re-ID will print out the is matching value. Okay, so we'll see it. In this case, it's very high. It's always above 90, but in other situation, it can change a lot. The query images. So these are important. That's why at the beginning we copied the images inside the NFS. It's because we can then say, okay, this is kind of a list of pipe separated paths. Like in the newest version, basically just provide the folder and then it knows automatically what to do. But here is basically we provide these 3 images, which are loaded and used as comparison, okay, to understand if the person is in the video or not. And again, we need to mount the also here the PVC to read from disk. So this is done. We can create a re-ID job. Creating. It's running. We can have a look at the logs. We go to the top, so a bit easier. So it started. It also exposes REST interfaces because you never know. Like this also has no Kafka, so we need to make it so that we can talk with it also when we don't have any other data plane available. Then it loaded the target query images. And this, especially these 2 lines, the following one here, is because before reading from disk, it will contact again the feature extraction service. So it gets the feature from it. Okay, it says, give me the feature vectors for these 3 images I provided you because we provided 3. Once that is done, it will load the data from disk. So all these .dat files. And for each frame, it will output this line only if the matching ID, let's say match ID, I think it's a confidence value. There is a bug. If the confidence value is above the threshold we provided in the YAML file. For example, here it tells me like user ID is synthetic. This is just the default. I found this time for this camera, there was a match and the ID is above, this is the confidence that I have. And you can see it's always very high because this is kind of it's a trivial example. It will process all the frames and then it will complete its job. Similar to the video analytics, we can go get pods and it's completed. Now, we can remove it for now. And we have a look at the result. So we go re-ID. As you can see, the .dat files are gone because it's made so that when they're processed, they are removed. The result will be in images. Synthetic because it's, if you have different users, so you can at least separate. It will be all the images with the result. Here there are, okay, it's not result, it's fine. I will show directly what's inside, and this is the output of the processing. They're a little bit small, and actually they are 702 because I forgot to delete the old ones, but basically it's multiple times the same, and you can see frame by frame, like the output of the ready. And so the carrier is identified. They are very small, I know, but they have number 1 and number 2 at the bottom of the box, which are the tracking ID generated by the detection module. Then carrier is something that comes from the REID. Probability, so proximity risk and these distances are calculated by another module that does the distance calculation between, for example, the two bounding boxes. It kind of does a projection. It draws the ellipses to see if there is an intersection to estimate if they're actually at risk. Okay, so this is the this kind of ends the kind of gives you the whole the complete overview of starting from a machine without anything on it, how to get to this point, so deploying our AI workflow. What is might be interesting for you to do if you want to try is to try with your own video. So maybe you have a video, any video, as long as like recommendation MP4 format, and then you provide the query images, JPG. You modify the REID, you modify, for example, the input video for the video analytics, and see what it comes out. Okay, so if it's able to process it, I recommend small videos. Don't have like I don't know, 4K, 120 FPS videos that are. I think it because it's not going to work, or it's going to work, but it's going to take too long. So I recommend like a short video, not low quality, like normal quality, and then you try to provide some query images and see what kind of results you get. After this, like the other thing you can, maybe if you want to do it, is to clean up the cluster. But as you can see, the only pod that remains is the service of the feature extraction. We technically can remain there, but if you want to undeploy everything, you can delete the jobs. This is what I did already, but you can also delete the service with this command. Okay, so that's everything from my side for this kind of demo. I recommended you. I mean, I told you what you could do to modify it. But if you have any questions or something, please go ahead. If you want to know how would this work, for example, in a distributed fashion, I can also tell you how would this play out and how would it work.
Thanks, Vittorio. Can you hear me?
Yes, I can hear you. Yes.
Yes, I think it's a very interesting demo and also a complex one. I think there's some questions on some things doesn't work on the chat.
Yes.
I don't know whether we can debug it.
I will
right
open
away,
it. No, here. No, this. So you're trying to create the feature extraction service. Error when creating YAML. Okay. Strict unknown field. Metadata labels. Did you register the wait a second. So do you have the global manager running on your cluster? So I mean so Stefan, right?
Yes.
Yes. So did you follow these steps? Wait a second.
I've tried to follow the steps truthfully.
Yes.
I might have missed something, but if you can point me, I can check.
Yeah, it's kind of it doesn't recognize one of the fields, but labels technically should be. Let me have a look what's on the repository here. Which one here? Because maybe the YAML file uploaded as a mistake in it. So you tried. No, this is one of the YAML files from SEDNA. Okay.
Yes.
Did you modify? So you didn't modify anything in this one, right?
The IP.
Only the IP and nothing else.
Yes.
Okay. I don't know. Can you share the screen? Is it possible so I can have a look and maybe tell you what commands to run, and then I'll try to help you?
Sure, if it's possible.
I don't know if I can.
I gave you access.
Okay. Share screen. Okay.
Okay, that's fine. Can you run? Let me see if there is the. I can see the chat again here. Okay. You can do okay if you closed the file.
Well, one second. I have to juggle around the mic.
Yes.
Okay.
And then you do k get pods minus a, or kube control get pods minus a. Oh, so minus. Did you put minus a? Because I don't see the one from SEDNA. I'm curious about the one from SEDNA.
How do I? What?
Minus capital A. I wrote it in the chat.
Minus
Because see, the GM is pending. So you have GAM, KB. You have a few things that are not in running state. Also the yeah, there is also the node. So this is on this machine. Do you have Kubernetes?
I just ran it on my laptop.
Okay. Okay.
I don't.
Yeah, like so. First of all, the CNI is not working. So there is the Calico node. There is of that, and also, for example, the GM and KB are in pending state. I'm not sure. Also, the Kafka and Zookeeper.
All right. So I guess okay, maybe I just have a way to different environment. I should have done this in the
VM. Because it's so that's why I think it's very important that the first part where you set up the infrastructure, you're sure that everything is running and it's good. Because if they're not all running, then it's very hard to debug. Because right now, for example, I know why you get this error is because the YAML file, so the definition of this service, the feature extraction service, is not recognized because the GM is dead, basically.
Okay.
Because the GM understands what the feature extraction service is, and then it can parse the fields in the YAML.
That sounds a bit difficult to debug. But
yeah, it is.
Yes, in a predefined VM, it might run. Okay. Okay.
Yeah, in a predefined VM, it should run without problems. Yes.
I'll stop sharing.
Thank you. I think let's continue for maybe 15 minutes. If you have any questions, you can ask Vittorio.
Yes, of course.
And always you can email him in case we can't resolve this today.
Yeah, if you have any other questions or would like to know how to combine this with KubeEdge. So, I mean, I can see that I don't know how many people in here already are familiar with Kubernetes in general. So for people that maybe don't have much experience, it could be very overwhelming. There are so many things that you don't really, that are hard to understand the first time. So yeah, that's why the KubeEdge part is not shown in this. So in this demo, But you can very well deploy the same thing also in a Kubernetes mixed with KubeEdge cluster.
Yes, I think we recorded the whole video for both KubeEdge and SEDNA, and also the demo should be available online in a week's time, so that you can follow at your own pace. I mean, I come from a HPC background, and for me, this is overwhelming, to tell you the truth. But I think it's very interesting to see how things work in a
like I share your thoughts. Is because it's even just having like probably setting up Kubernetes and all the pieces that will require like a few hours maybe to make sure that everyone is at that stage, and then adding on top the extra framework is also definitely extra challenge. I'm here. If someone got like stuck somewhere else or needs some help, I'm happy to answer. Otherwise, you can always reach me via email.